Welcome to the Exec Exchange, 15-minute podcast in which a leader from the water sector shares a story to inspire, educate and inform other water sector leaders around the world. My name is Piers Clark, and today my guest is Kjetil Wang Hansen, the Chief Executive at Veas in Norway, the largest wastewater treatment plant in Norway, I believe.
Thank you. It's a pleasure to be here.
Now, looking at your background, you are a man who not only likes complex projects, but you positively thrive on them. You've been drawn towards them. So tell me a bit about your background.
When I was a child, my dream was to become an aircraft mechanic. I moved to the west side of Norway when I was 16 years old to study aviation in high school because I wanted to be an aircraft mechanic. So after 2 years in Stavanger, I joined the Air Force officer school and specialized in F-16 fighter jets. I worked as an aircraft mechanic for a few years, and then I studied to become an engineer. And eventually, I led the engine and component workshops where we maintained all aircraft systems for the Norwegian Air Force. So first a part of the military and later as a separate company called Air Norway that we established.
I am prepared to bet my kidneys that you are the only wastewater treatment plant management operator that has got a pilot background.
I think you have right.
When did you join Veas?
I joined Veas in 2015 after some projects setting up an engine depot for the F-35 fighter jets. I started because I got the main responsibility for 2 children and combining business trips while having these children. They were 2 and 4. It was too heavy, so I changed job and started at Veas in 2015. I thought it wouldn't be as exciting as aviation. I thought that I will be here for maximum 5 years. I think that with all the developments happening in the water industry, I think this is one of the most exciting fields to work in. And now I have been here for over 10 years and no plans to leave.
The aviation industry's loss is the water sector's gain. That's brilliant. And congratulations on your 2 children. Let's now talk about what it's like running a water utility in Norway. And tell me a bit about Veas. It's a wastewater utility, not a drinking water utility. Is that correct?
That's correct. Veas is a wastewater facility, and we were founded in 1976 by 3 of Norway's most popular municipalities, Oslo, Asker and Bærum. And we started operating in 1982 with only 26 employees. And since 1995, we have been treating nitrogen and have grown significantly in the recent years. So now we are 104 employees. And in addition to our production team, we have departments for maintenance, projects, development, quality, and a full-scale laboratory.
How many people does Veas serve?
We serve approximately 800 to 900,000 people in the Oslo area.
And this is the biggest wastewater treatment facility in Norway.
This is absolutely the biggest wastewater treatment in Norway.
This creates a really interesting dynamic because for some of the people who listen, they'll be running utilities that serve many millions of people. Can you just take 30 seconds to talk me through the structure of the water sector in Norway?
This structure is small sites and they are owned by the municipalities. And we have a lot of communes here in Norway. And we got this EU directive we have to follow now. The rules are not there yet, but all these small facilities have to start with nitrogen cleaning. So that will be a challenge in Norway right now because the plants are so small.
So you've got lots of very small municipalities with very localized teams trying to comply with European legislation, which is quite cumbersome and demanding upon you. And you've got the added challenge of Norway is a cold area. How do you go about doing wastewater treatment plant design and operation when you are operating in the climatic conditions of Norway?
In colder areas, as you say, lower temperatures can slow down biological processes. To help with that, you can, of course, heat the water. For our scale of plant, it's too much water. It's 3,000 liters each second coming into our process. For us, it comes in a long tunnel. It's a tunnel of 40 kilometers, and the temperature varies by about 10 degrees Celsius throughout the year. And the biggest variation is due to snow melting. But what we have seen for the last 10 years is that the weather is more unstable, and we can have heavy rain in the wintertime. And then we have snow melting and cold water coming in.
The temperature variation is what, 0 to 10 degrees C, or is it 5 to 15?
Now it's more 5 to 15. But what we can see is that our process with the biological treatment is running good also in the wintertime. For us, it's not a big problem. Actually, because of the stable temperature on the tunnel, we sell the heat energy. We sell approximately 110 gigawatt hours to a district heating system, which is feeding Oslo Centrum for approximately 10% of the need in the wintertime.
So a lot of your wastewater comes down a 40-kilometer pipeline. The temperature is very variable and is about 5 degrees lower than what we might experience, say, where I am in London. But because of the long tunnel, you're not experiencing that temperature variability when it gets to the works. Is that what you're saying? Or is it because you do the heat recovery that you're softening the volatility of the temperature change?
No, it's because of the long tunnel. So the temperature stays steady and the tunnel is going 15 to 20 meters below the ground. So you have thermal heat from the tunnel from the mountain.
How's the heat recovery working?
We are just selling the energy. There are a couple of plants taking out the wastewater from the tunnel and put it in a heat exchanger, and then they spit the sewage back again to the tunnel.
You're just letting it be diverted out so that they can steal the heat. And they're taking the heat in the winter and using it for cooling in the summer, or do you not have a cooling problem?
They are using it also for cooling in the summertime now, more and more. But originally it was only for heating in the wintertime. They actually pay us for this energy.
So you've got your biological treatment that is working steadily, even though you're at these low temperatures. Is that because you've done anything particular to optimize it for low temperatures, or have the bugs and the bacteria in the plant merely adapted?
I think the bacteria is adapted to the Norwegian climate. When we design new plants, we know that it can be a challenge, but our experience is that this is working very well.
And what do you do with the solids that you gather?
The solids, it's going out to the farmers. So last year we sent out 45,000 tons of solids to the farmers in the eastern part of Norway.
Is that done as raw sludge, or do you do a pre-treatment?
We treat the sludge. We add the lime to it, and we also heat treat it. So the dryness of it is between 40 and 45%. So it's quite solid when it goes out.
The wastewater treatment process you're using is conventional primary settlement and then conventional activated sludge, is it, that you're using for nitrogen removal?
No, it's a special process. We use a chemical process, which is very fast. With the normal active sludge, the wastewater is using maybe 24 hours through the process. But our plant, it only used 3 hours. So it's chemical based and it's really fast. It's like Formula One.
Can you comment on what the chemical is? What can you say about that?
We use aluminum and we use iron. And we use carbon, like methanol, and we use air blowers. So we add oxygen, like air, in the process. I don't think so many plants in the world have this type of process. I haven't seen anyone else.
Does it have a proprietary name if anyone wants to research it? Is the process called something or sold by a particular?
We just call it like a chemical-based process. But they can call us and we can give some more information.
Now, tell me about what your plan is for utilizing the resources and how you're hoping to create more value from the wastewater.
Maximize the removal of nutrients and harmful substances from incoming wastewater and minimize the environmental impacts of operations and maximize economic and environmental benefits to recovering resources from wastewater and turning them into profitable products and services. And today we sell over 100 gigawatt hours to heat-based Pump Central, and we sell bio-LNG. We upgrade over 90% of the internal biogas. So we are producing bio-LNG also from external CBG.
It sounded earlier like you were producing a raw sludge that you were then doing lime stabilization, but the lime stabilization is coming after you've done anaerobic digestion.
That's right.
I missed that. And without aerobic digestion, does that have thermal hydrolysis? Because I know that there are some very famous Norwegian companies that do thermal hydrolysis. Do you use a Canby facility?
No, not yet, but we have bought one. We are actually building it now. So within maybe 1.5 to 2 years, we will have this Canby sludge process, which is called solid stream. The solid stream, it's a bit different from the normal THP. You have this damp explosion after the digesters.
For those people who are listening and are not familiar with anaerobic digestion or indeed thermal hydrolysis process, this is going to suddenly get very technical. But typically, you have the thermal hydrolysis process before anaerobic digestion, and then that enhances the digestion process. The new process that's being proposed and launched and sold by Canby is where you move it to after the burst digestion process. And I believe the effluent then goes back into the digester, so the bugs get a sort of second bite of the cherry.
That's right. So you feed with the reject water from the thermal heating or the dewatering afterwards. So you feed the reject water to the digesters again, and you will cook soup on it twice. So it will give us more biogas in the process, maybe 15% more.
I've watched what Cambia have been developing with a degree of quite a lot of excitement. My background, my PhD was back in anaerobic digestion, and seeing some of the things that they're proposing, they really are quite radical. I wish you the absolute best with that.
Also, interesting part that we are producing this liquid biogas. Now we will upgrade the CO2 from the biogas plant. So we will put the CO2 to this Northern Light project in Norway. So we will remove approximately 8,000 tons from the atmosphere and store it.
So you're going to sequester the CO2. So you're generating biogas, you're cleaning up and liquefying it, and then you're going to clean out the carbon dioxide and sequester it in a local carbon sequestration project.
That's right. That's right.
Kjetil, this is so exciting to hear, especially as a limited utility in terms of the resources. Only 109 people, I think you said. You haven't got hundreds of people, yet you're showing some great leadership and embracing of innovation. Let's finish with a question about what is the best advice that you have ever been given?
Perhaps not the best advice, but it's something I think about occasionally in projects here in Norway, which is a small population. And that's when I were working on the project to establish the F-35 engine depot. We started sketch phase and design outlet for the depot. And in Norway, we often think small and in smaller scale than in the US. And I remember that Pratt & Whitney, the engine supplier for the F-35 fighter jet, they made a comment that we have to think bigger than we normally use in Norway. So you have to think big is something I often reflect about. And perhaps it's a part of the reason why we are now thinking bigger in relation to new regional treatment plant for the future. We are also planning to build a new treatment plant, and it will be maybe outside the mountain, and it will be maybe bigger than we have at Veas today. So go big or go home.
You have been listening to the Exec Exchange with Piers Clark. Today, I've been talking to Kjetil Wang Hansen, the Chief Executive at Veas in Norway. I hope you enjoyed it, and I look forward to seeing you next time.